Got it. Okay. So yeah, starting back at exercise 1, this was all the information we got off the house, right? The ceiling height, the perimeter, the gross walls, the total windows, the windows that face north, east, and west and south, doors, net walls, ceilings, floors, above grade volume. So what we're going to do is we are actually going to take that information and put it in this simplified Excel load calculation sheet. So first off, let's discuss some of the stuff here. Remember, so the project I put as exercise 1 for obvious reasons. The design state and city is Fairfax, Virginia. Remember, all of these numbers are what you would need to use if you were doing a load calculation in Fairfax, Virginia. That means the indoor design heating dry bulb is 70. The outdoor design winter dry bulb is 17. That makes our heating temperature difference HTD 53. Indoor design cooling is 75. Outdoor design 1% is 95. Cooling temperature difference, or CTD, is 20. Our indoor design relative humidity is 50%. That gives us a 46 grains of difference between inside and outside for the purposes of calculating latent loads. Our daily range is medium. Latitude and elevation is mostly a non-factor, and the altitude correction factor is 1, which is mostly a non-factor. So to rehash, these are the values we will always use for our exercises, okay? To keep it simple, these values will not change. So, as we do these exercises, I'm going to give you guys this a copy of this sheet with all that stuff always filled in, so you don't have to do it. Remember, if you're doing loads in a different area, those numbers will need to change. But for the purposes of what we're doing, we don't care. Alright, we're just going to practice doing everything as if it's in Fairfax County, because it keeps everything nice and simple. So, we will, I think what I want to do is, because this is a slightly different version of what I used to teach out of J7, what I want to do is I want to do glass direction heating. So that'll be our all glass, and then we'll do north, east, and west, and south separate. And then there's a separate line available there. Skylights is here. Let me put a line there. Clean that up a little bit. Alright, skylights are here. We won't be using that today, so it's no big deal. I give you a few spots for wood and metal doors. We really should only ever use one. As a matter of fact, let me see if I can... just trying to clean up the way this sheet looks. That's not going to work though. Anyway, no, we'll just leave it as it is. So there's a few spots for wood and metal doors, 2 spots for above grade walls, 2 spots for below grade walls, a line for ceilings, a line for floors, exposed floor, slab, or basement floor. Then we get down to infiltration and stuff, and I don't want to talk about that yet. So what we're mainly trying to do is fill out these sections. If we can get everything filled out up to here, we'll be in good shape on doing a load calc. Okay? So all of our windows and heating will come here, and we'll put the construction number for that here. And then we'll put the ones for cooling here and fill that in. So this will be, we're going to gray this out because there should be no number here. We're going to gray this out because there should be no numbers there. Same thing, gray, gray. That way you know you shouldn't be putting any numbers there, because I like to split them up between heating and cooling, so we've got that total to work with, and then we've got that cooling to work with. So again, this is just a simplified version of an actual speed sheet. You should be able to fill all these out essentially the same as you would the actual ACA speed sheet that you can download online. So, switching back real quick, let's look at our house. We have 8-foot ceilings. Was there somewhere to put that? Was there somewhere to put our ceiling height? No, it doesn't look like it. Alright, perimeter is 124 feet. We don't need that on this, but that would go on slab floors if we had one. We're just going to skip that over that for now. There should be a spot for gross walls, right? I could have sworn there was a spot. Maybe they move it over. It might be somewhere else in the speed sheet, and I already closed the other one. Yeah, let's just skip it, because we don't actually need gross walls. That's really there to give us other calculations, so we'll just skip it. Normally I would give you somewhere to put gross walls on here because it makes life easy, but alright, so looking back, total windows 207 square feet. Alright, that includes our glass door, remember? So there's 207 square feet of windows. So if we switch back to our Excel program, what you'll want to do is put in your net area on all of these. So for heating, we had 207 square foot on windows, because in heating, glass direction does not matter. It never matters, okay? So then we can look back at our load, and we can put in north, east, and west, and south for cooling values. So that's 117, 60, and 30. So we switch back to our Excel sheet, and we put 117, 60, and 30. And we have nothing on this line, and we have nothing on this line because that's skylights. Wood and metal doors was 21, and we'll switch back and see that in a minute. But I remember we only had one door, so we stick in wood and metal doors there. Right there, doors was 21 square feet. Net walls was 764 square feet. So let's put that in. Above grade walls. None of these are above grade walls. We'll get to how we know that in a minute. But this is basically going to be kind of like a rancher style house over a crawl space. So 764 above grade walls. This is a single floor house over a crawl space, so we have no below grade walls. Our ceilings. Our ceilings are 840 square feet, and our floors are also 840 square feet. So we'll input those last two numbers here. Exposed floors, it's going to be under exposed floors because they're neither a slab or a basement floor. What did I say, 840? Double check. Yep, 840. So 840 square feet. So if I make you guys fill out this sheet, you'll have to know which one of these lines come in, which you'll understand soon as we kind of go through these examples. But this is where you put those areas, right? Net area, that's all the net areas. This is always the first thing I do, which is why that's the first thing we practiced, okay? First thing we practiced was getting all the areas so we can automatically input those. Everyone follow me so far?
Looks good.
Okay, so that's what we learned the last two classes. That's where we get our net areas. That's how we input that column. Once we got that column inputted up to that point, we're done with all that. So all that work is to get that row of or that column of information done. Now, what we want to work on is inputting construction numbers. Okay, so to input construction numbers, let's look back at our house. On every exercise, what I will give you, and in the real world, what you need to find, okay, is what's everything made of. And there's going to be bits of information you need on everything, and it's all going to be a little different, but this is what you need to find. After you've done all this work to find the things, you need to put a note when you're doing this drawing. What kind of windows do you have? What kind of doors do you have? What kind of walls do you have? What kind of ceilings do you have? What kind of floors do you have? How much insulation is in the walls, ceilings, and floors? That's what you need to find. So, an example of a decent amount of information on windows would be they're double pane windows. They're operable, which means you can open them, right? So they're openable windows or operable windows. Whether they're clear glass or some kind of reflective or low E coating, or generally clear glass and low E can go together, right? But clear glass, whether or not there's low E, which I haven't noted this here, but if there is a low emissivity coating, then you would put that on here if that information's available. What kind of frame it has, the actual window when it was installed, what kind of frame does it have there? So was it a wood frame, vinyl frame, metal frame? Generally you can tell by what's around the window itself, right? So you look at the actual what's around the glass and what is that made of. If it's in a wood house, it doesn't mean it's wood frame. You need to know what the frame of the window itself is made out of. And probably next class we will talk about what the typical you see these days are. But what most of this stuff is kind of typical what you might have seen 15, 20 years ago, right? Whether or not there's a sunscreen, you'll pretty much never have a sunscreen, and we'll never have a sunscreen on our exercises. So that's probably the only time you'll see me put no external sunscreen, and we'll talk about that a little bit when we get there. But unless there is a external sunscreen built in for the windows, you put nothing there, and it's pretty rare in our area that you have an external sunscreen. And then Venetian blinds. Always assume that the window will have Venetian blinds if you don't know. If it's an architectural feature and it's a window that's going to it's up high or something, it's one of those little round windows, or it's some kind of like I said, an architectural feature. I can't think of a better way to put it. Something that's made to make the house look good, and they're not going to put blinds over it. If it's a regular operable window, generally you should assume Venetian blinds, unless they're going to put drapes or something like that. And we'll see that in the table when we get that far too. But this is what you always assume. If it's an operable window, assume it will get Venetian blinds unless you know better. Doors, is it wood, metal, or what? Is it a solid or hollow core? Does it have insulation in it? And whether or not there's a storm door. With walls, you should know what the frame is made out of, whether it's a 2x4 or 2x6 frame, whether it's cinder block, and whether the outside of that wall is vinyl siding or brick, or any other external covering, EFIS or something like that, and what the cavity insulation is in the wall. Okay, what's the R value inside the wall? Ceilings, what kind of ceiling it is, if it's a roof ceiling combination, under a ventilated attic. So is the ceiling all one thing? It's built almost like a floor, but insulation inside of it would be a roof ceiling combination. Or is it under an attic? Obviously, most of the time you're going to have under a ventilated attic. What kind of insulation is in the attic, and what color the shingles are. And then floors, whether it's a open or enclosed crawl space or garage, or it's a slab on grade, or it's a basement slab. What kind of floor covering they have or gonna have, carpet or hardwood or nothing. And then what the insulation is below the floor, if it's an exposed floor, or what the slab insulation is if it's a slab. Now, We'll repeat a lot of that a couple times so you'll get used to those things that you need to see there. And a lot of times I forget something that I needed. So as we go through the tables, you'll see all the information you need to be able to properly find the construction number. Okay? But you need to get as close to at least this much information as you can. The hardest thing if you're doing a load on an existing building, the hardest thing is usually to get the cavity insulation inside the wall. If you're not sure, assume, and it's an older house, assume at least R13. If it's a newer house, assume at least R19. Or if it was built in the 50s or 60s or something, you may need to assume no insulation. Could also, obviously, it could also be R11. Generally, you'll see almost nothing R11, R13, or R19. But if you don't know, just take a stab based on how old it is, basically, or get them to let you cut a little hole somewhere or look inside a hole and see the thickness of the insulation in there. Generally, they try and mostly fill the cavity of the wall if there's insulation in there. But you'll notice that it could be the insulation, I guess just you got to kind of look at it. But like I said, just do the best you can with it, because the walls, this is not the most critical thing, the cavity insulation in the walls. What's more critical is the windows, the ceiling, and then if it's above a crawl space, these floors. If you get everything right and you're a little bit off, if you put R13 but it's really R11 or R9, or you put nothing, if you put nothing, it's going to be a lot. If you put nothing, make sure it's nothing. But if you put, R11 when it's R13, or R13 when it's R11, or it's R15 or whatever, that's not going to kill a load too much. That's not going to be plus or minus 10% of that load, not even close. So don't get too hung up on that when you're trying to do a load on an existing building. As long as you're reasonably close, that's fine. Everything else is more important to get as close to right as possible. So after you get this information and you've got your areas done, we can find the construction values. Again, you guys should be on page 133 of your book, because that's where we're going to start, and I'm about to bring up that page. We're basically going to be doing it in the exact order that we have it. So we're going to do windows and glass doors first, then we're going to do wood and metal doors, then we're going to do walls, ceilings, then floors. We're going to do it in that order. And depending on how tonight goes, we may only get through windows, because windows gets kind of hairy once we get to cooling. There's a lot of things we need to understand. Like I said, when we're done, I'll post this as an example on Google Classroom. Look over it and make sure that you understand everything we're doing and read through your book. If you get lost here, it's going to be a bad time. Alright? So if you got questions, let me know. So, once we get this far, hopefully this was easy to follow up to here, because we haven't done anything complicated yet. You've got all this stuff. You picked up this information out of the house, or you're looking at the information that I'm giving you when it comes to our exercises. I'll always give you as close to enough information as possible. If I miss something, let me know. But if I don't put it, assume that it doesn't exist, okay? The only thing you should ever assume is Venetian blinds. If I don't put Venetian blinds, assume Venetian blinds. If I put drapes, then use drapes. But if I don't put anything on windows, assume Venetian blinds on everything. I want you to assume that. Okay. So, going back to our house for a second, let's pull up the tables starting on page 133. 133. So these are just copies of the tables right out of your book. So to get your construction numbers, and this is what we're talking about. We're talking about save this somewhere real quick before I start marking it up, because I want to give it to you guys marked up and not marked up. Here we go. There. Alright. So, when I say construction number, right here, this is what we're talking about. Construction number. Alright. This is the construction number. Okay, so this is what we're looking for when we're looking for that. We need to find the window, and this is table 2A, okay? And let me start back at the beginning. I'm going too fast. 133, table 2A, default performance values for generic penetration. This is for heating only, this is not for cooling. So this is where you're going to get the construction numbers and U values that you're going to need to input into the program or into the table for windows and heating. Okay? The nice thing about this is that the formula that you're going to use for each table is at the top of each table, okay? So you will need to find on your page, or on your you'll need to find and put on your worksheet. You'll need the heating HTM and the load. The load is easy because it's always HTM times the load area. But the HTM that you have to input into the table, okay, right here, let me bring this up a little better. Heating HTM is what we're working for. So we're trying to find this number. So we want, when we're looking at table 2A, we want something here. This is where we're trying to put it, okay? We want something right here. So we need to find that number. Well, we're trying to find the heating HTM, right? So if we go back and look at this table, it tells us heating HTM equals U value times indoor design temperature minus outdoor design temperature, or our heating temperature difference, right? The HTD number. So we already have our HTD, which is 53. Okay, we already figured that out at the beginning of this worksheet. We've already talked about that. So since we already have that, we don't even have to do this section in parentheses. Okay, all we have to do is U value. Let me put a box here. All we have to do to get our HTM is U value times HTD. So an HTM stands for heat transfer multiplier. Our heat transfer multiplier, what we're trying to find is how much heat is moving through each square foot of window. Okay, so for every square foot of window, we lose X number of BTUs on the coldest days of the year, basically. The coldest days that we're designing for. So, to find that number so that we can figure out how many BTUs we're losing through all the windows, we need to have that HTM. The HTM is our U value times our HTD. So the U value is what we're going to find in this table with the construction number. The construction number tells us where we got the number. So if I say we have a 1A-C window, we know that we have a single pane operable window or sliding glass door, clear glass, and then we just need to know whether or not it was, which frame it had, the type of frame. So the only thing you'll be missing out of that is the frame. So yeah, that construction number tells us where we get the number. Then we look up this U value and input our HTM. Alright, so that's what we're trying to do. For now, what I want to work on, just to clarify again, is I just want to figure out where we get our construction numbers, so we can input construction numbers into our table. That way, if we've got the construction number, we can then find whether or not we got the rest of the numbers right, because it really doesn't matter as long as you can input a construction number good, okay, then everything else is good from there. And what I would recommend is, because it separates metal no break, metal with break, wood with metal clad or vinyl or insulated fiberglass, we'll put MNB, MWB, W, or IF after our construction number. You don't have to do that, but it'll help you remember what you had. Okay? The best thing you can do is give yourself enough information so that you know where you got the number. Alright, so in this table, we are going to figure out which window we actually have in our mock house here. So going back to, oh no, we were right, we're on Bluebeam. I need to switch here. So looking at our house again, I said we have double pane operable window, clear glass, wood frame, no external sunscreen. That's for cooling, so that's not important yet. And Venetian blinds, that's only for cooling, and that's not important yet. So we're looking for double pane operable clear glass wood frame. Generally, your sliding glass doors, even on new houses, are going to be the exact same construction as the rest of your windows. If it's not separated out, but it's usually the same or so close it doesn't matter. So, looking back at our table, this first line, right? Number 1 is clear glass. Okay, so let me double check something here. Yeah, they don't even give you anything for anything else on wood windows. They used to give you a couple other options, but I think they simplified it with J8. Pretty much every window's clear glass anyway. So you're always going to be clear glass for our exercises, so it's really not that important. Are we single pane operable or single pane fixed sash? So not operable. No, we're none of those, alright? Are we double pane or hold on, single pane with storm? No, we're not single pane with storm. Double pane operable window or sliding glass door? Yes, that's where we are, right? All these things line up with what's on our sheet. All the stuff we just said. Double pane operable clear glass is right here. Done. Double check that there's nothing else that fit. Double pane window fixed sash? No. Triple pane window? No. Triple pane window? No. It's not a Jalossi window. It's not a projected window assembly. It's not a bay or a garden window, and that's a little different anyway, but we don't have any bay or garden windows. And none of these are French doors, right? So none of this matters. So we're double pane operable window. So we know we're a 1D-C, right? 1D-C. This would be the construction number that you should input into your table. Alright, so let's switch to Excel. We need a construction detail. Our construction detail is going to be a 1D-C, and then you can note whether it's wood, frame, or any other thing. There's a lot more space in this construction number space than there used to be, so we can just put 1C. And I mean, if it helps, you can write the rest of it, wood frame, single pane, whatever. But for the most part, you'll find when we get further down to the wood doors and stuff, just having this number here is enough to tell you everything else. Windows are the only one where that little bit doesn't tell you pretty much everything about it. Okay? So 1D-C wood frame. Oh no, it's double pane. Why'd I put single pane? Wood frame, double pane, window. Alright, so that's heating. Simple as that. We're not going to input the HTM yet, but that's our goal. But we know that our heating window is a 1D-C. Switch back. We know that our wood frame window is a 1D-C. And just to jump ahead for a second, it's wood frame, right? So we're going to be right here. So we'll use that number later this class or next class. So, when you do the window, just to recap, you're going to find how many panes you have and whether or not there's a storm on a single pane. And you're going to find this row, okay? And then you're going to find the column, alright, and get your U value. Ignore the SHGC. It's not important, okay? The only important number is that U value. Remember, our formula says U value times indoor design temperature minus outdoor design temperature, or HTD, right? We don't care about this SHGC number. It's there for other reasons, so just ignore it. For the purposes of every exercise we do, you don't need that number. Finding this row and this column is what you need to do. Find that number, and then we're going to use that number later. And windows and heating is that easy. This is probably one of the easiest ones to find, because you're generally always going to be in this table, especially for classroom purposes, but still, even in the real world, 90% of the time, windows and heating is going to be right here. That's all you really need to do. Find the frame type. Double pane operable is going to be your most common. A lot of times 0.57 is going to be your number. Done. Alright, so that's first construction number out of the way. Moving on. I skip a couple pages on you and we go to 3A-1. You can read table 2A notes and everything, but do it on your own time. After that, go to page 137. Alright. Finding windows and cooling. This is a little different. So first off, let's look at the formula. Cooling load BTUs equals HTM times load area. Notice it does not tell us how to calculate the HTM. So in heating, we got a formula to calculate our HTM, right? Heating HTM equals this. In cooling, they give us no formula for that because we won't be doing it. Bay windows and stuff have different things, and we're not going to talk about that today. It's not important. The mandatory adjustments. I want you to pay attention to this because it's very important when we get to HTMs. I want you to pay attention to this. Alright? Read it. Understand it. We will talk about it when we actually input our HTMs. But you need to make sure you do those mandatory adjustments, which is mainly whether or not there's an external overhang and whether or not there's an insect screen. An insect screen actually makes a relatively large difference on your HTM. So the outdoor insect screen is the most common one you have, and it's usually a full or half insect screen, and it multiplies, it's 80%. The HTM ends up being 80% or 90% of what it would be otherwise. So you need to make sure you make that adjustment. For now though, here's the thing with windows and cooling. The construction number is easy, okay? What I need you to put for the construction number every time, especially for the purposes of this class, we will pretty much always be using this table, okay? We'll be using this table 3A for Windows, alright? So you're going to be, for Windows and cooling, you will always be, for the purposes of this class, on page 137. We won't use any other 3A tables. If you look through your book, you have 1, 2, 3, 4, 5, 6, and then 144 is skylights. Which, did I get skylights? No. I may add skylights in there later, but I don't know if we will do any exercise with skylights. But anyway, there's multiple pages of tables. The only one you need for Windows and cooling is page 137, table 3A. So going back to our construction number, the easiest thing to put in there is always going to be 3A. 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 Alright, there's your construction number. You already have wood frame double pane here. The only thing you might want to add in here so that you've got the information is whether or not it has an insect screen. No. Dadgummit. Why is it all caps? So I would probably put insect screen. No. And I will probably put whether or not you did blinds or drapes or whatever else. So if you want to put Venetian blinds there or something, or what do they call them? They call them horizontal blinds at 45 degrees. Horizontal blinds 45 degrees. So you may want to put that. It's up to you, but really the only number I'm going to make you put here is 3A. That's the important number, so that I make sure you knew what table you were in when you got this, okay? So the construction number is easy. The hard part is actually finding where you're at in this group of tables. So I want you guys to pay close attention here, because even if you don't understand what we're looking for on any exercises we do, you'll be right 90% of the time if you just do this. Because 90% of the time, we're going to have a double pane window, clear glass with Venetian blinds. Okay? That means if you look at this table, 90% of our exercises, I might throw a single pane curve ball at you once or twice, but 90% of the time will be right here in this set of columns. Because this set of columns is single pane, this set of columns is double pane, this set of columns is triple pane. So all you do is pick this column based on how many panes the window has. Most windows out there are double pane windows unless they're old, then they're single pane. It's very easy to figure out how many panes the window has by looking at it. For just 1 minute, you can go up, look at it, and actually see how many panes of glass there are. So, 90% of the time will be in this set of columns. Then you have this set of rows is for no internal shade, so no blinds and no drapes. This set of rows is for Venetian blinds, or vertical or horizontal blinds with slats. This set of rows is for drapes or roller shades, half drawn, and this one is for fully drawn. Alright, give me just a second. So, remember I told you to always assume Venetian blinds unless you know better. If you know there's not going to be any blinds, then use this first row. But most of the time you're going to be in this second row. So most of the time you're going to be right here. All right? I'm just going to shade this a little bit. Most of the time you're going to be right here. All right? And again, for the purposes of this class, we're only going to be doing north, east and west, or south. So you're only going to be doing this row, or this row based on direction. Okay? Then here are our design cooling temperature difference. We need to find our design cooling temperature difference. Well, that's real easy, right? Because we've got it in our worksheet right here at the top. It's 20. So we go here, and we know we're in this column right here. What all this boils down to is we've got 3 numbers to pick one from. Usually you're going to be picking 16, 46, or 24. 16 for your north windows, 46 for your east and west windows, and 24 for your south windows. Done. Okay? The most important thing to remember is these 3 numbers. Now, that doesn't mean that can't change, and I won't throw a curveball at you and say, you know, we've got single pane windows, so you should be over here at 26, 61, and 35. Or that there's no internal shade on this window, so you'd need 24, 73, and 38. But for the most part, these are going to be your default values right here. So if you're in any doubt at all, make sure you're right here on this page and you're picking these numbers, and you are likely to have it correct on most installations out there, because this is your most common 3 values for those windows. I mean, period. Hopefully that helps. This number has not changed since manual J7. None of these numbers have changed. This has always been a good estimate of cooling for loads, or cooling loads on windows. The only thing you have to do is then you'll need to adjust this HTM on whether or not you have an insect screen. So if we do have an insect screen, you'll have to get the table HTM and multiply this number based on whether it's full outdoor, half outdoor, full indoor, or half indoor. But you'll be, this is where you'll get it from. And again, I'll have this marked up page so that you guys can refer to this if you need to, if you forget, with all these rectangles on it. So hopefully you remember how we got there. But that is how we get there on the windows. So table 3A, the numbers will always be there. As a matter of fact, I'm going to just input those now. As cooling HTMs right there. Because generally, those are going to be, 46. Those are going to be your cooling HTMs. But don't always double check. You shouldn't assume. But if you have to assume those numbers and you're probably safe. Okay. Skylights, we're not doing skylights. Okay, after we get through table 2A and 3A, okay? As soon as we get through those tables, everything gets a lot more straightforward with construction numbers. After that, we move on to table 4A. 4A is opaque panels. Opaque panels are ceilings, floors, doors, and walls. Okay, so opaque panels, the heating HTM, this gets kind of complicated, but for the most part, it's the same as a 2A window, and it's the same as a 2A window, and the only reason they say reference area is because on slabs, sometimes you use the square footage, and sometimes you use the perimeter. I've said that a bunch of times, so hopefully it's sinking in by now. But that's the only reason it says reference area. Most of the time, this is going to be square footage. The exceptions are number 15, 19, and 22. Have more complicated formulas, okay? But it's not that important. We're going to get to these and do examples of them. But just understand these are your formulas unless it's one of these construction numbers, and then you have different formulas and you can reference that again here. Alright. For cooling applications, it's the cooling HTM equals the U value times the CLTD value. We're going to get there. Don't worry about it. But this is basically the cooling. I like to think of it as the calculated cooling difference. There's a what the heck does CLTD stand for? I always think about it in my head as the effective cooling difference, but I always forget what CLTD actually stands for. Let me see if I can find it real quick. I always forget, man. Cooling load temperature difference, I think. Yeah, cooling load temperature difference. But basically, because you have to account for the sun and other factors, radiant heat loads and everything else, you can't just use the straight up temperature difference. You have an effective temperature difference accounting basically for radiation, heat from radiation, and actual temperature difference heat. Okay? And then default design temperature is always 75, and passive floors on cooling has basically no U value. We'll get there. But as far as construction numbers go, it's easy as heck. So the first two numbers is always the table we're in, and that tells you what you're working with. So construction number 11 is all the doors. So if you're doing a door, alright, if you're doing a door, oh, I didn't switch, guys, sorry. Hopefully you're looking at page, the right page. You should be on page 4A. So again, I was just talking about these formulas at the top of your page, and that's page 147. So these are the formulas that we're going to talk about more later that I was just going on about. But the important thing for tonight is the construction number, okay? So construction number 11 is all wood and metal doors. So if you're doing a wood and metal door, you should be in construction number 11, period. Because once we get to 12, we're talking about walls. So doors are always pretty easy. It should be an 11 something, okay? And you've either got hollow core with wood storm, hollow core with metal storm. And then repeat for solid core, that with wood or metal storm. Then a panel door with wood or metal storm. For a metal door, does it have a fiberglass core or fiberglass core with storm? Honeycomb core with storm, so on and so forth. These are going to be the difference. With metal doors, this is probably the hardest thing to figure out, is what the actual core is. Again, doors don't make a huge difference. So if you at least get the fact that it's a metal door right, I would just err on the side of slightly more BTUs with a fiberglass or paper honeycomb core. Unless it's a newer one, then it's probably polyurethane. But either way, don't worry about it too much, because if you've got a metal door, it's probably going to be a very small factor on your load calc. Everything else is usually easy to figure out. You can generally tell whether or not it's got a honeycomb core or a hollow core, and you need to account for that. The door will be very light, and you can tell it won't be built very well. So, if we look back at our exercise, I said we have a wood solid core no storm. So, wood solid core no storm would be right here. We have no storm door, we're wood solid core. So our construction number is in 11D. Alright, 11D. So we'll go back to our Excel sheet, and under doors we'll put 11D, and that tells us all we need to know about our door. Done. Doors should be easy every time. Walls are where things start to get tricky. Okay? Walls can take a minute to find. So let's look at the wall tables, and let's talk about walls. It's not hard, but you have to pay attention. Alright? So if you keep going, we figured out our doors, and now we got to figure out our walls. So let's, again, for the purposes of this exercise, we have a 2x4 wall with vinyl siding and R13 cavity insulation. That's all I told you. Okay? So you got to figure out which one of these. You got a few pages worth of tables. Which one of these? You have construction number 12, and that goes for 2 pages. Construction number 13 goes for 4 pages. Then you have, then you get into basement walls, and so on and so forth. So, construction number 12 is framed walls and partitions. So in other words, 2x4 or 2x6 walls. Okay? These are all 2x4 or 2x6 walls. Then you get into block walls. Okay, so you have block walls. And then you have these or these. Alright, and then whether or not it's got another stud cavity in front of it on the block walls. So if you have a wood frame wall, alright, you're going to be looking for, I think we got to go back one more page. Yep. You got a wood frame wall. The first one will say no insulation in stud cavity. Alright. Well, let's talk about this for a minute first. You see how they make up this wall? This number is always going to be 12, okay? Or 13. Walls are always generally going to be 12 or 13 if it's above grade, right? So if it's a wood frame wall, to be 12. If it's a block wall, to be 13. And then you have exterior finish code is B or S for brick veneer or stucco or siding. Alright. So stucco and siding is an S. Brick is a B. So if you have brick on the outside, it's brick. If you have stucco or siding on the outside, it's S. The framing code is generally going to be W for wood frame, unless you actually have a metal frame, which they don't even give you in this. If you've got a metal framed house, you really, I think you're supposed to use the full manual J8 to do it for whatever reason. And then the reference area is the gross wall area minus area of windows or doors. So basically your reference area is net walls, right? So your reference area always equals net walls. That's why we put the number in there. See, some of this stuff I don't know why they write like this, because it just makes it sound complicated. But Dang it. A reference area is net walls. Okay. So 12A is no insulation in the stud cavity. Okay. 12B is R11 insulation in the stud cavity. 12C is R13 in the stud cavity. 12D is R15. You see the pattern? Every letter is more insulation in the stud cavity. So again, looking at what we have again, we have 2x4 R13 in the stud cavity. So we go back here, go no insulation, no, we have insulation. R11, no, it wasn't R11. R13, yes, it was R13. So we got this far. Now we know we're in this section. Okay? We know we're here. After we get that far, we need to know basically whether or not it has board insulation, and if the board insulation, what the R value of that is. So if there's board insulation on the outside of the wall, okay, it'll be siding or brick, then board insulation, then the stud cavity with insulation in it, then your drywall wall generally, right? If there's board insulation on the outside, then you need to put that. If it's just wood sheathing, okay, if it's just wood sheathing right here, then you're in the first one. So if I don't say anything about board insulation, you're going to be right here, okay? You're going to be right here in this first top row, unless you have board insulation. If there's nothing said about board insulation, assume that it's wood sheathing, because that's relatively common. Board insulation's becoming quite more common, but for now, wood sheathing is still kind of your most common one. After that, you just need to know whether it's siding or brick, and honestly, a lot of the time that doesn't even matter, because there's your HTM, and then this is where you get your cooling load temperature difference number from, which does change whether it's siding or brick, okay? But for heating, it doesn't matter. So since we said we had siding, we're going to be this right here. We're going to be a 12C because we're R13 insulation, 0 because we don't have any R value on this. That number is the R value for the board insulation. S because we have siding, and W because we have wood. All of those numbers tell you something. 12 is that it's a wood frame wall. C is that it's R13 insulation. 0 means it's wood sheathed because there's no board insulation. S means we have siding, and W means it's wood framed. So our construction number for our wall will be a 12C dash 0 SW. Let me double check I did that right. Yep, 12C-0SW. Oh, I didn't switch you guys. Oh, yeah, I did. 12C-0SW. There is our above grade wall. Now, just to flip through, obviously, the other numbers you could have are all through here. And then if it was a block wall, then we'd be a number 13, right? And we'd have to pick whether there's blanket or board insulation, whether there's siding or brick, whether it's open core, and whether there's wood framing on the inside. So for instance, a common wall for above grade, you really don't see above grade block that often, but if you did, you're probably gonna see something like a 13 CA, 13 CA, block. Oh no, that's no exterior finish. So C 13B, C. Let me just go ahead and 13CB. So 13 concrete block, no board insulation, any exterior finish, R13 and stud cavity, open core block, plus interior finish, and you'd be there. You know what I mean? But usually we're going to be doing wood frame walls because that's the most common. Block walls are generally underground walls, which we get to down here. Block walls are partitions. Basement walls. So you have these block walls for above ground sections, right? And honestly, for the above ground section, you're usually going to be R11, I think. Yeah, so something like that. Anyway, we'll do a block wall exercise at least once, but it's the last thing we'll do after we've got walls down pretty good. But yeah, you got your block walls and you got your basement walls. Basement walls are below grade, and how far it is below grade with basement walls matter when you're doing one. And then whether or not there's insulation board. And we keep going. There's more basement walls, construction number 15. You keep going. Some more basement walls. And then we get to ceilings. Alright. So ceilings. Now we got to input our ceilings, right? So far, just to recap, we've gotten a construction number for our windows, construction numbers for our doors. We got construction number for our above grade walls. We don't have any below grade walls, so now we're going to do ceilings. So looking at ceilings, to get that construction number, you're going to have a few tables for ceilings. You're going to have 16B, which is a insulated ceiling under an attic, which is by far your most common ceiling. It's not your only one, but by far that's your most common. Okay? Then if you don't have an attic space above the ceiling, you could have a ceiling on exposed beams, but that's kind of not too common. You're going to be sort of like a log cabin kind of thing if you have a ceiling on exposed beams. What you're generally going to have is a ceiling below roof joists. So plywood deck on wood joists, board insulation on deck or insulated joist space plus interior finish. Generally, I probably should just left out this table because we'll probably never do an example on ceiling on exposed beams. We're usually going to be a ceiling below roof joists or under a ventilated attic. So 16 tells you you're under an attic, 17 is a ceiling on exposed beams, and then 18 is a ceiling below roof joists. Okay? After that, so we're going to be a 16, right? Because we're below a ventilated attic. We're R30 insulation, so ceilings are pretty easy. You have a 16B, which is vented attic dark shingles, 16B 30, because that's our insulation value. We did do R30 on this one, right? Yeah. 2x4 vinyl, no. Under ventilated attic, R30 dark shingles. Dark shingles, under ventilated attic, R30. So there you go. Roofs and ceilings do not have a group number. So your U value is right here. For your U value. And then for your cooling temperature difference, you're right here. So on ceilings, we are going to put 16B30. 16B-30. There's our construction number. Floors. Last one we need to do in our first set of finding construction numbers. Alright. So floors. Go back to our little drawing. Floors, we have a few options, okay? We have, starting on page 160, we have floor over an enclosed unconditioned crawl space or basement. So this would be an exposed crawl space or an unconditioned enclosed, okay? So the operable word here is if it's an enclosed unconditioned crawl space or basement, okay? This is generally, you're going to see this most often on a basement, but it's becoming a bit more common for people to enclose their crawl spaces, not have ventilation. If they do enclose their crawl space, it needs to be conditioned in some way, okay? Just enough to mitigate any structural problems. But if the crawl space or it's a basement is unconditioned and it's completely enclosed, you are going to be a construction number 19. And then you need to know whether or not there's floor insulation or there's insulation on the exposed walls. They should give you that somewhere. Where's that at? It's not important, I guess. But it is actually important whether or not the wall is insulated. Maybe you have to do a full J8 for that. You might have to use a program to do that properly. But yeah, whether or not there's insulation on the walls is important. This is assuming there's no insulation on the walls. Alright, then we get to a open crawl space or garage. So if it is not enclosed but the crawl space is vented or open, and most crawl spaces are ventilated, so there'll be holes in the side of the crawl space to allow air to circulate in the crawl space, and that just keeps you from having too many moisture problems and things of that nature, right? Which is why if it's enclosed you have to condition it somehow. It doesn't have to be fully conditioned, but it's got to be partially conditioned. If it's an open crawl space, you just allow the outside air to go across it, right? Those are those houses that always has the pipes frozen underneath of them if there's no good insulation, right? Or they don't do it well. But anyway, if it's an open or ventilated crawl space or it's a garage, then you are construction number 20. And then after that, you get into basement floors if you have a basement floor. And then you get to slab on grades if you have a slab on grade. Okay? So we'll talk about those another day when we do an exercise that has those. But for now, we are on our floor. We are open or ventilated crawl space, carpet floors, R13 insulation. So open or ventilated crawl space, R13, you see how it has board and blanket here? If I don't put the type, assume blanket, because blanket is a bit more common than the board, alright? So if I don't put a type, assume blanket. If it's board, I'll say board. So R13 insulation right here. Alright. So it's a 20P 13 floor right there. R13, blanket insulation, any cover. So that means the fact that it's carpeted doesn't matter. Mainly with slab floors, it matters whether you have hardwood, carpet, or tile or vinyl. So I always put that, or if it's no insulation, it's important on a open, on over a crawl space. But there you go. There's your floor U value, and then here is your cooling load temperature difference. 20 M. We haven't talked about that too much yet, but there's your temperature difference. So the U value is the only thing that changed. The cooling load temperature difference basically always stays the same. So wait, oh, we got to fill it out. I almost skipped it. So it's a 20P-13. So let's do that. Exposed floor is a 20P-13. And once you get all the construction numbers, then we know that you did it right and found all the right numbers. Any questions? Stop sharing. So